Today's notes are on the properties of logs, expanding and evaluating. Please try the warm-up on your own and then look at the box below. The properties of logs that we'll be using today are the product property, which says if you have log base b of u times v, it is equal to log base b of u plus log base b of v. So for example, if I have log base 3 of 9x, that is equal to log base 3 of 9 plus log base 3 of x. The next property is the quotient property, which says if I have log base b of u over b, that's equal to log base b of u minus log base b of v. So for example, log base 2 of x over 5 is equal to log base 2 of x minus log base 2 of 5. And the last one, number 3, the power property, is log base b of u raised to an n power can be simplified by bringing the exponent down in front of the log. So log base 4 of x to the 5th power is equal to 5 times log base 4 of x. So looking at example 1, we are going to use the fact that log base 9 of 5 equals 0.732 and log base 9 of 11 equals 1.091 to approximate the value of the following expressions. So the first thing I can do is use the quotient property to rewrite this as log base 9 of 5 minus log base 9 of 11. Then I can replace them with their approximate values. So log base 9 of 5 was equal to 0.732 according to the problem, and log base 9 of 11 was 1.091, and if we perform that subtraction, we get negative 0.359 as our answer. Looking at example B, the first thing that I'm going to do is to rewrite 55 to be 5 times 11, since I know what log base 9 of 5 and log base 9 of 11 both equal. Then I'm going to use the product property to pull this apart to two separate logs. So log base 9 of 5 plus log base 9 of 11. And then I'm going to replace them with their approximate values. And this time I'm going to add them together to get an answer of 1.823. The last one we're going to do together is C, log base 9 of 25. The first thing that I'm going to do is rewrite 25 to be 5 squared, seeing as we don't know what log base 9 of 5 equals. Then I'm going to use the power property, which brings the 2 out front. So I get 2 times log base 9 of 5. And I can replace log base 9 of 5 with 0.732. which gives me an answer of 1.464. We will look at the other two problems on the bottom of this page together in class. For example 2, it wants us to evaluate each logarithm without using a calculator. So we have two options for example A. The first is to rewrite this as 2 logs. So I have log base 3 of 3 plus log base 3 of 9 and then I can rewrite the second one to be log base 3, and instead of 9 I'm going to rewrite this as 3 squared, because by doing this I can use the inverse property that told us if we had log base of the base that it was equal to the exponents. So I really have 1 plus 2, which gives us a final answer of 3. Or our second option for this problem would have been to multiply this to get log base 3 of 27 and then rewrite it as a base of 3. So instead of 27, I'm going to have 3 cubed. Then log base 3 of 3 equals 1. So then I have the exponent. That gives me an answer of 3. We're going to do the same thing for B. The first thing I can do is bring the 3 out front. Then I want to rewrite the 4 so that it's a base of 2. So instead of 4, I'm going to write 2 squared. And log base 2 of 2 goes away. I'm left with 3 times 2, which gives me an answer of 6. And then last one, example 3, I'm going to start by getting rid of the fraction by making this e to a power of -3. Then, knowing that the natural log and e are inverses of each other, they cancel each other out, leaving me with an answer of -3. The last thing we're going to talk about is the ability to expand and condense logarithmic expressions. So to expand a log expression, you're going to use the properties to make sure that the argument inside the log is a single number or variable. Remember that all of your exponents will become coefficients. So the first thing I'm going to do is to expand this to be log base 5 of 2 plus log base 5 of x to the 6th power. So my first term is good. It only has one number inside of the log. The second log, we need to change the exponents. So we have a log base 5 of 2 plus, we're going to bring the exponent down to be 6 log base 5 of x. And that will give us our expanded form of the log. We will look at all of the other examples tomorrow in class.